Here they're asking us to show that this trigonometric identity is true. So this isn't an equal sign, it's an identical to. So what you do is you try to manipulate the left-hand side to make it look like the right-hand side, or use an identity that you know is correct, manipulate it and make it look like this. Now, when you see squared on both sides, I think the first thing you should be thinking of is sine squared theta plus cosine squared theta equals 1, because we know that's an identity that we all know. And how can we make this look like that? Well, it looks like if you divide by cosine squared, then that'll give you 1, and 1 over cosine squared is secant squared, and sine squared theta over cosine squared theta will give you tan theta. So not quite. Maybe if you divide by sine squared, that seems to make sense, because 1 over sine squared will give you cosecant squared. Sine squared over sine squared will give you 1, and cosine squared over sine squared will give you cotan squared. So that, I think, is the answer. So 1 plus cotangent squared is cosecant squared. That should have been an identity. Yeah, there you go. So that's part A, only one line involved. Now for part B, it's asking us, it's telling us that y is the cosecant inverse of x. And they're saying, okay, if you rewrite that as x equals cosecant y, find dx by dy, show that dy by dx is that. Okay, so this is rather tricky. Let's start with this. X equals cosecant y. How would you find dx by dy? So you'd need the derivative of cosecant. Now there are several ways to find the derivative of cosecant. They might give it to you in the formula sheet on your paper. You could use the quotient rule, you could use the chain rule, but generally they give it to you in the paper. So the derivative of cosecant is minus cosecant cotangent. Yeah, minus cosecant cotangent. So dx by dy is minus cosecant y times cotangent y. Now, this is strange because they want us to find dy by dx, and there's no trig functions in there. So we probably need maybe to use this identity or some other identity to get rid of cosecant and cotan. So that's dx by dy. Let's find dy by dx. That should just be 1 over cosecant y times cotangent y. Now, cotangent is just sine over cosine, isn't it? And cosecant is 1 over sine. So if you think about it, what we actually have is minus, let's write it the long way. So cosecant is 1 over sine y, and cotangent is cosine y over sine y. So these denominators of the denominators can go up here. So you end up with minus sine squared y over cosine y. So the question, there is no trig function in sight and there's no y's. only x's. So can we replace cosine y and sine y with something that relates to x? So y is cosecant inverse of x. So that means x is cosecant of y. And so x equals 1 over sine y. Oh, that's convenient. So I could have actually just replaced that with x and that with x. Right, so that actually makes more sense. So you've got minus 1 over x times cosine y x. So that gives you minus 1 over x squared cosine y. Now we still need to get rid of this ugly cosine y. We don't want a y in there. We want x. So because we know that sine y is 1 over x, let's write it the long way. So if I say x equals 1 over sine y, that means sine y is 1 over x. That means that sine squared y is 1 over x squared. And we know that cosine squared y is 1 minus sine squared y. So that's that same identity that we used in the beginning. I've rubbed it out now, but this is the same identity. So that means that cosine y is the square root of 1 minus sine squared y. And if you remember that sine squared is just 1 over x squared, so we can say cosine y is square root of 1 minus 1 over x squared. We can then use that in there. So you've got equals minus 1 over x squared times 1 minus 1 over x squared. So we're almost done. We just need to do something with the denominators there. So we could, let's clean up a little. We could say minus 1 over x squared square root of x squared minus 1 over x squared, and then this denominator goes up there. So you have minus square root of x squared over x squared minus 1. Square root of x squared is just x, and that will cancel with the x squared in the denominator. So it's minus 1 over x squared minus 1. So I think that's what they asked for. Yeah, x squared minus 1. There. So that was a lot of work. We had to use a few tricks. One of the tricks they told us about in the question, but we had to use quite a few others like that, and using the identity and then common denominator. So that was quite a lot of work. I don't know how many marks that was, 5 marks, but quite a lot of work for 5.